What's up, guys? So today we're going to take on the monumental task of summarizing 7-week Revature training in, I'm going to shoot for 7 minutes. Cool. So we should probably have a clock. Cool. This is way too big. Let's make it manageable. How small can we make it? Will it go smaller than this? I guess not. All right. Cool. 7 minutes starting now. So the first thing, week 1, we learned Java, Git, and OOP. So this is like if you want to be a full stack engineer, right? Before we go through this, I feel like we should go through the entire structure of it. So the entire point, where's the clock? The entire point is like we want to build applications. An application has 3 parts. Has the database, the back end, and the front end. The front end is the part that the user sees. Like we're looking at Google Docs right now. We have this clock. All of this is front end stuff. The user sees it, clicks on it, does the stuff, right? Then you have the back end. The back end is like the front end sends data to the back end for processing. It can do like logic, it can do a whole bunch of stuff, like literally all the logic it can do. The reason we don't do that logic on the front end is because the front end lives on the user's computer, which is called the client. Come back. Which is called the client. But the back end lives on our computer or our server. So we don't want to do too much logic on the user's computer because it'll slow it down. We want to do the minimum there, and also for security reasons. Anything that is like computatively difficult or shouldn't be out in the wild because of security reasons, we're going to do in our server in the backend. And then you have the database. The database is if you need to store information, um, like persistence is the word. You need a persistent data storage, a place where you can store data and not worry about it getting lost. So that's the database. It literally looks like an Excel spreadsheet. It has, except instead of one table, it has like a bunch of tables, and those tables can be related to each other. I'm talking SQL databases here. So this is it. So if you learn this and you can build applications with this, um, you have basically learned that's what Revature is going to teach you. So the first step, I think, if you want to learn this, is to first build an application using a database, and then build an application, build a backend, and connect it to the database, and then, and you can test that backend using Postman, which we're going to talk about in a sec, and then build a front end using HTML, CSS, JavaScript, and connect that to the backend, and then you have an application, and then just practice that over and over and over again using these technologies or similar technologies, and you like if you do that, you've basically that's what we did at Revature for 7 weeks. So week 1, Java, Git, OOP. Now, what is Git? Git is a version control system. You know how on Google Docs 2 people can work on the same thing at the same time um, without messing each other up? Git is like that, but on steroids. So you guys know about like GitHub and stuff like that. So you can have a repository which stores all your code. You can have branches which are like versions of those repositories. Git is also good so that like where are we? Git is good so that we can like I can work on something on my local machine. I can do some git commands like git add, git push, git commit, and these will help me push it to the remote machine. And if anything messes up my computer, I'm good. Like my code is good. So that's what Git is for. OOP is a way of thinking about writing code. And as part of this, the main things are abstraction. I should write these in the doc. Main things are abstraction, inheritance. Well, let me start do polymorphism. Abstraction, polymorphism, inheritance, and encapsulation. And you can remember these with the acronym APIE or API. If you want to actually understand this stuff, I'm not the best guy to explain it, but there's this good dude called Alex Lee. Literally anything that has to do with Java, if you're a beginner, look this guy up, watch his videos, take notes. This guy saved my life. Without him, I wouldn't have gotten into Revature. So you can look up like Alex Lee abstraction. He has videos about every single one of these things. But if you have an interview, they're gonna ask you this for sure. Or we're definitely not gonna make 7 minutes because we're still on week one, but that's okay. So uh yeah, they're gonna ask you about this, like abstraction, polymorphism, inheritance, encapsulation, all this stuff. And you need to know what they are and give examples. They probably won't ask you to code examples, but you should at least know what they are, especially for Java. So speaking of, what is Java? Java is a back-end language. So all of these three layers, they have their own languages. The database works with SQL or SQL. Um, you can say it however you want. And the backend works with Java. There's also C Sharp, which is really popular, and a bunch of other stuff. Like you can do Python. You can do what else have I heard of? You can do PHP, right, with Laravel. So it's basically there's a bunch of backend languages. They help you do a lot of processing, a lot of logic. They're usually much stricter than the front end languages. The front end languages are JavaScript is the programming language, CSS is the design language, HTML is the structure like document language. So, but if you want to learn um, backend, the most popular language as far as jobs is Java. Every big company uses Java. I'm not the best person to teach you Java. I'm still learning a lot of it. But this website will teach you every programming language, the beginning of it, even HTML, even CSS. When I was a kid, like 14, 15, 16, I used to play around a lot on this website with HTML, but they also have Java. And the good thing about it is it's not just like it has exercises and examples, and you can like it has quizzes. So you could like if you do the quizzes, you basically understand the fundamentals of every programming language that you get the quizzes of, at least the syntax. So go through these. Also, there's a book for Java. One thing that really helped me understand it was books. Also my friend, I have a friend who's like a big fan of this website, O'Reilly. So I should recommend this because it's a little bit more financially, it's better for your pocket than what I'm about to talk about. Not auto parts, books. Yeah, this. So they have a subscription and then you can read like all the books you want. I'm currently reading this book. I feel like they should sponsor me, but they aren't. So, but this you can, I think you pay like 45 bucks a month. You get access to all these books electronically. But this book right here, my auntie gave me this book and it helped me understand Java. It took me like a year to understand Java, to be honest with you. It's really hard and really strict. But if you want to do backend stuff, it's important. And if you want to get jobs, it's good to know Java. Um, Java and JavaScript have no relationship. But you can think of Java as like the more strict form of JavaScript in a way, but they really have no relationship, despite the name. So that's week one. Uh, Week two, Gradle, test-driven development, SQL, Postman, JSON. So I'm going to start from the right and then move in. So JSON it stands for JavaScript Object Notation. And it's a way of basically your front end sends data to your back end sends data to your database. They need a way to talk to each other, like that they both recognize and understand. This is actually a really hard computer science problem, but the most popular way is JSON. You could also use XML. XML, you can look it up, but it looks like HTML. It's like the old school way of sending data. But JSON literally, I'm not gonna look it up, but you should look up like JSON object, what they look like. It's a way of storing data, just a syntax for writing data. So that you can send it as JSON from your front end to your back end. Your back end can like what is it? Serialize it or deserialize it and then use it. And then it can send it in I forget what format, but it sends it to your database and then your database stores it. And of course, you can get it from your database to your backend, to your front end, and so on. So that's JSON. Uh, while I'm on it, before I forget, there's four methods. They're called HTTP methods. So There might actually, I actually think there's more than 4. Also, this website is really good. This and the W3 schools, these are the top websites for learning like the front end part, in my opinion. This has everything that you need to know about HTML, CSS, JavaScript. It's the documentation, so you should read it. But you have GET request, which just means give me some information. You send a GET request to your backend, it'll give you some information. You have a POST request, which means take this information and probably store it or verify it or something. Like when you do a login, you send it to your backend, you use a POST request. Uh, Put is similar, but like you don't have to send all the data. You can forget about that, but you can read more about it as well if it interests you. Delete is what it sounds like. Just get rid of this data. Get post. There's also patch. Yeah. So partial. Oh, I think that's actually. Yeah, never mind. So patch and put patches, you don't have to send all the data. Put, you have to send all the data, but it's for modifications. Post is like the first time you send it. So there's these HTTP methods. They're important to know because that's how you're gonna send things from your front end to your back end. Um, and there's some other stuff as well for which it's important to know those methods. So that's JSON. Postman. Now, post has to do with sending data. Sometimes, like if you built your backend but you didn't build a front end yet, you would use Postman to test it out. I actually have Postman on my computer, so I'm just gonna, if it'll open quickly, because my computer is really old, I'm just gonna show it to you. But it's just an app. You can download it from you can just install it on your computer. And once you build your backend, you'll have like a link, which if someone sends a request to that backend, it can get some information. And if you don't want to build a whole front end to test it out, you can just plug that link into Postman and send the request that way. We'll come back when Postman is fully open. SQL is a way of getting data. It's like an interface for your database. So you can open up your database and look at the Excel spreadsheet basically and get data that way or read it. But you can also just write SQL. It's super simple, super easy to understand and read. And I'll show you like what it looks like. Again, note this website. It's super useful. This is what a database table looks like. So pretty basic. You'll say select all from customers. It'll give you everything in the customer table. There's a bunch of dialects of SQL, but they all kind of look like this. You have select statements, update statements, delete statements, all that kind of stuff. It helps you send stuff and get stuff from your database. Test-driven development, really important, even though I neglected it a lot in the beginning. All right, we'll come back to this. Yeah, so test-driven development. Um, so when you work with code that's very large, uh, you know how like it feels like when you change one piece of code, it breaks another piece of code. You change that code, it breaks another piece of code. And when you have code that's very big, it's hard to know this change that I just made, did I break something else or not? So in order to figure that out, you write unit tests. There's actually 3 kind of tests, but the one we're talking about here is our unit test. So if you write a method, you write a test that says, does this method work? It's like a way of testing the method using software, using code, instead of actually manually testing it. So you can write an app and test it by clicking around, which is tedious, or you can just write a unit test. Just write a unit test and run it, and the computer will tell you, yes, this code works or it doesn't work. It's pretty magical. But test-driven development is a crazy idea, which is actually a good idea, which is done a lot in companies, which is don't write the code first. Write the test first, then write the code, um, and then like make sure the code passes. There's like 3 verbs. It's like fail, pass, and then basically make it right. Like make it fail, make it pass, make it right. Something like that. You can look it up. So test-driven development means if I want to make an app that um, helps me feed squirrels, first I write all the tests for feeding squirrels. Like it should feed the squirrels should be happy, the squirrels should love me afterwards, like all the tests, right? Then I write the code that does it. No, then I run the test and the tests are going to fail because I haven't written the code yet. Then I write the code and then I see like, okay, the tests are kind of passing. I write the code so that I make the test pass. And then um, after the tests are passing, I refactor the code to make it perfect. So at first I just write it and then I refactor it to make it perfect. So this is important. Every interviewer that I've encountered really wants you to know this and do it because it makes working on large code bases easier and sometimes possible. Like sometimes if you don't have tests, it's impossible to work on a large code base. It's actually, you can't do it because you change one thing and then something else breaks. But this isn't always practiced perfectly in the real world. Yeah, so just keep that in mind. It's ideal. Ideally, we should all do it, but most of the time, people write code first and then write test. But regardless, you should always write test. The variance is just, is it test driven? Is your code test driven or is it just tested? Regardless, though, tests are really important. All right, Gradle. We'll come back to Postman. Gradle is a way of, it's a dependency manager. So again, I'm going to give a really bad explanation, but oh, it's a build tool. Sorry, it's a build tool. See, I'm already messing up. Like in Java, you could write everything yourself, but there's also things, code that other people have written that they have exported that you can import and use in your code, which is great. How do you manage all of that external code? You use Gradle. So Gradle, like I don't want to talk about it too much because I'm going to say things that are not technically correct. But Gradle is like an addition to Java. You have your plain Java, you can write code with it, it works. But the larger it gets, the harder it is to manage. And the harder it is to load all those dependencies and make them run well with your application, your Java application. So you use Gradle. There's also something called Maven. Maven and Gradle are like the same, like they do the same thing, but they're slightly different. If you know one, you should be able to learn the other. So I'd encourage you like look these up, read about them, but don't obsess too much about it. Just know how to do it. There's also important if you're using Gradle and your code isn't working for some reason, um, obviously rerun it. But if that doesn't fix it, you need to do a Gradle refresh, which saved my ass a lot. So that's week 1 and week 2. Let's see, how are we doing on time? 16 minutes. Cool. We're crushing this. Awesome. So week 3, HTML, CSS, JavaScript. This is the fun stuff, the easy stuff. So I say easy to learn. Java is hard to learn. This is easy to learn, but there's still a lot of depth in it, especially in JavaScript. So I think of HTML as like a skeleton. Let's say you want to build a human. Okay, this is the weirdest front end example you're ever going to hear. So I think of HTML as like a skeleton. It literally is like, let me show you some HTML syntax. Let's see. Cool, nice. I just want to see some code. Also, when I was learning this stuff, ChatGPT did not exist, but I would encourage you to ask ChatGPT like, hey, show me some HTML code, explain it to me, all that kind of stuff. So let's see, is this? Yeah, nice. We'll use this, sure. I don't know if you can actually see this, but because of where it is on the screen. Yeah, so look at this. So you have like tags. So if you wanted to write like a title, is there a head? There is no head. Anything you put in this body tag is going to show up like in the body of the web page. This H1 stands for header. This is like the biggest size of header. So H1, it helps you format text basically. This P stands for paragraph. So if you write something in H1, it's going to be really big. If you write it in the P tag, it's going to look like a paragraph. You can do bullet points. You can do whatever. Like the computer doesn't know what a bullet point is or what a paragraph is or what a header is, but it knows when you wrap it in these tags, it knows how to show it. So the browser is going to read your HTML and based on that, display something to the user. So that's why some text in the browser is really big like this, some is small, some is bolded. HTML does all that and does a really good job of doing that. So that's HTML. It's it's the skeleton. It gives your text shape. That's why I call it the skeleton. All right, let's talk about CSS. So if you were building a person, you'd have like a skeleton, right? Let's talk about JavaScript first. So JavaScript is like the muscle. So you can have code, but how do you make it do stuff? Like for example, this is a button. There's a button tag in HTML. So that's why this shows up as like a button or a link, something like that. But if I click on it, what makes this thing appear? Like what adds functionality? What makes my web page do stuff? You know, that's JavaScript. So JavaScript, you can program things. You can say like, if user clicks this button, show this. If they do this, show this. It adds muscle to your web page. It's like function. It tells makes your web page able to do things. The same way muscle adds like functionality to a human, like you can get up, you can move around and stuff. That's what JavaScript does to your web page. Adds logic and muscle. CSS is like the clothing or the skin. It makes your web page look pretty. Like all these colors. If there is no CSS, you can do it with HTML, but it's really clunky. But it adds like color, styling, makes it pop. I wish I was good at CSS. Just it makes everything look really pretty or professional or artsy or whatever you want. It's like the most artistic part of programming in a way. All right, I didn't forget about Postman. Let's go back to Postman. So we don't have a Java program running right now. Let's see. Can you guys see this? Yeah, you can, right? Yeah, you can. Okay, cool. So we don't have a Java program running right now, but if we did, we would ask it, would say, hey Java, run this on port 8080, and it would obey us. And then we would have like a controller class that has this mapping. We would send a post request. Remember the earlier verbs? So if we sent a get request, let's look at things that were already get request. Like I was building an app for eBBO or EFIC dictionary words. So that's where this is from. It will go to the author class and fetch all the authors. All we would have to do is press this. So instead of building a whole web page to test like, hey, does it actually get all the authors, which could be cumbersome and then take a lot of time and we have to change it if it's not working, we can just build the backend and then test it with Postman. So Postman is like our fake front end, you know? Before we build the front end, we test with Postman to make sure everything works. It's really good for debugging. It's really good for a lot of stuff. So that's Postman. So that's week 3 and week 2 and week 1. Nice. Nice. All right. So at this point, have we covered databases yet? Not yet, right? Did we? We covered SQL, which is databases. So by week 3, wow, by week 3, you can basically build an application. Right. It's not very advanced or very good, but you can do it. Like you can build a backend, you can build a database, you can build a front end. But the future part are all these tools that make it slightly better. Um, to build a backend, you might need a little bit more than Java can give you. But you know Gradle. What do you need to build a controller? There's this tool called Javelin that can build a controller for you. So there's like Java. It's not really Java, but it's like other libraries that people made using Java, and you can plug them into your code using Gradle. And yeah, I think you can build a backend, but it's hard. Like it's way harder than it has to be. Let me say it like that. On the front end, you can build a website with HTML, CSS, JavaScript, no problem. There's also this thing called Bootstrap. If you have no sense of style, if you're whack and you don't want to learn CSS or you're a beginner like me, you can learn Bootstrap. So Bootstrap will help you make your web page look good without having to write a bunch of CSS. It's like someone else's CSS and you just steal it and use it, and it's free. So it's awesome. So you can build an application, but this next part is how to make it easy, make it good, make it like professional and stuff like that. So actually, I take it back. You can't build a web page if you don't know Fetch. Fetch is like the API, JavaScript API that lets you send requests from your front end to your back end or to someone else's back end. Part of why we call this an API is because it doesn't have to be yours. There are APIs out there that you can Google, and some of them are free, and you can just build a front end and then use them. Someone exposed those endpoints, and you can use them. They're really cool. So API means application programming interface. It's like I would say like the application programmer can use that interface to access someone else's backend and their database, right? Yeah, their database. So it's really cool. But fetch is like, think of it like a messenger. You can use it to you tell it like, hey, go get this from this link, just like Postman was trying to do. You write it in your JavaScript and it will go and do it, and it'll come back with some, I think it's JSON that it returns. It returns data in some format. And then you can use that data. You can take that data and then display it in your HTML. So HTML can contain stuff that you typed out, like that paragraph tag and so on, but it can also contain stuff that you get from a database, which is the real magic, which is really cool. So you should look this up. Fetch API is really the full term. Then you have GCP. GCP, sorry, did not mean to do that. GCP is a cloud technology. So cloud just means someone else's computer, right? We know this. So if you build an app, like I can build a website on my computer using HTML, CSS, JavaScript, but my mom can't see it. Like no one can see it. But if I host it on GCP, GCP means Google Cloud Platform. It means Google has a bunch of servers and they're gracious enough to rent it out to me. So instead of having to go and buy a server all at once, I can use GCP and ask Google, hey, here's some code. Use your server and display it on this port. And here's this website. I can link it to a website, like a domain name, and then you go to that domain name and you see my website. So GCP does that. I learned GCP, but I'm actually learning AWS right now. I just got the practitioner certification. I would recommend you to learn AWS instead of GCP. Um, as much as you have a choice, I just found it way easier. I spent 3 weeks trying to set up a server on GCP to host my application, like 3 weeks, and I could not do it. Now that I know what I'm doing better, I could do it, but on AWS it was a lot easier. So, but they're the same thing. There's three cloud providers. There's AWS, which is Amazon Web Services, GCP, which is Google Cloud Platform, and there's Microsoft Azure. So you should play with all of them, learn all of them. Docker. This is something I'm still learning. Um, man, so how do I put this? So I'll give you an example since I don't understand it well enough to explain it to you. But like at the company I'm working at, my new job, we have local development. Like we're making an app on our laptops. And then once we're done, we push it up and then it goes live, right? Incrementally, like continuously. Like we're always pushing it up and then it gets you get an update. So Docker, we we use Docker to simulate like an Amazon S3 bucket on our computer and to simulate like a PostgreSQL database on our computer. It helps you like keep the versions of things the same, and it's also a virtual machine somehow. And also I know that people can publish their own packages on Docker and you can like use those packages. So there's like a whole community there. But I've probably spent cumulatively less than 4 or 5 hours on Docker. So I literally couldn't explain it to you what it was. Um, but yeah, it's good to know it. It's like you can spin up a machine, a virtual machine using a Docker. You just write a Docker script. And then every time you run the script, it'll like produce a database for you, produce a S3 bucket and so on. And it'll keep all these things in sync. It's like that. Let's see what Google says about it. Virtualization. Yeah. Yeah, I know some of these words. So it's definitely good to know about this. If you're entry level, I don't think anyone's going to expect you to set up a Docker container, or they might, I don't know. But yeah, that's Docker. Learn as much about it as you possibly can. All right. All right. So now we come to Angular, the bane of my existence. I hate Angular, but some people love it. It's like, so let me not sound unprofessional. So you have HTML, CSS, and JavaScript, right? You can build what you want with that, but the problem with software as I like as I see it now that I'm new to it is like everything works, but what works when things get big? Like what works when um, a code base gets really large or a company gets really large? In that case, you need a way to organize your front end code. If I showed you like some basic code that I wrote by myself, it has like 40 files. Like maybe some of them are HTML, some are CSS, some are JavaScript. You need a way to organize them together. So there's these three tools. There's Angular, which is this. These are called web frameworks. That's right. There's React, which is this, which I've also played around with, and then there's Vue, which is what I currently use for work. Oops. So you should look these up and learn them. I would recommend starting with React because it's the most, well, your choice. React is the most popular. Vue is the simplest. I'd recommend learning React, to be honest with you. There's just a lot more jobs for it. Um, yeah. But the gist of these things are that they organize your front end code into components. So everything becomes a component. Like this window is a component, this document is a component, and then inside this document, every button is a component. Not really, but maybe like this header is a component, this sidebar is a component, and importantly, it lets you build single page applications. So um, like if we go to the MDN docs, if I'm on this page and I want to go to HTTP, watch this refresh thing. Oh, actually, it doesn't do it. Okay, cool. Let me try. Like if I try to see how it refreshes, that costs like time, and depending on your network, it might be slow. But if you have a single page application, it loads everything at once. Like I think Gmail is a single page application, and it's like the new way the web works. So a lot of times when you try to navigate between things, the refresh won't happen. It'll just show that component and then take it away when you're done with it. It loads all the components at once and then just shows it to you depending on the logic, which is really cool. That's the best thing Angular brings to the table. So that can be good, like because you're loading everything at once. But if someone's internet connection is really bad, that first load might take some time. Like the first time you open Gmail, if you notice, it takes like a few seconds. But then afterwards, it's really fast. That's this single page application thing. So you can read about that, and if you talk about that, that'll make you seem that'll be good. I think interviewers and like that makes you seem like you really understand what you're doing, even though you're new to it. That's the secret. And then you have Agile. So Agile is a philosophy. Agile is a way of life. So Agile is in software development, it's like, what's the best way for us to develop software quickly and easily? So Agile is a way of doing that. It's more like a business term. So for example, if a company practices Agile, they'll usually have stand-ups every day where every team member will get together and present. Um, they'll say like what I worked on yesterday, what I'm working on today, and my blockers. Those are the three things. And they'll have rituals like that, and that is a technical term, rituals, where that are supposed to help all of us work together better and keep all of us on the same page and make us efficient as a team and things like that. So I'd recommend you look that up and read about it. Um, I've only ever worked in an agile environment. There's this other methodology called waterfall, which is different. I've never worked in that, but I like the way all the teams I've been on work. Maybe I've been lucky. So I would recommend agile, even though I haven't used whatever the opposite of agile is. And now we come to the big dog, which is Spring Boot. So Spring Boot, I'm just gonna look it up, even though I know what it is and I work with it literally every day. But um, yeah, this is not helpful. So you guys look it up, but I'm gonna explain it as best I understand it. Okay. So most of the time, because Java is an old, boring, stale language that's literally older than I am, uh, there's a lot of tradition and things are done in the same way most of the time. So Spring Boot, there's a big thing called Spring, and then it has parts of it. Like there's Spring Boot, there's Spring Data, Spring Web, Spring Security. All of these are ways of making your life easier as a Java developer. In fact, I was so pissed at Revature because at the first time we went through things, we learned Java without Spring Boot, and then we learned Spring Boot, and everything was literally a lot easier. So the boot part is like when you're booting up your computer. Spring Boot does that for the first time you set up an application. So there's literally a checkbox, and you can be like, oh yeah, I want it to be a web app. I want this, I want that. And it'll set up your application for you and load in. Remember Gradle? It'll load in all those dependencies along with it. It uses Gradle. I think it can use Maven as well. And it'll just set everything up to the point where I've forgotten for the most part how to set up like a Java application. I just use Spring Boot. I download Java and then I use Spring Boot to set up a new application. So it's very nice. There's also Spring Data, which helps you um, handle your data with your database. It's called an ORM. So it instead of you having to write SQL, raw SQL, you just write Java, and then the Spring Data writes SQL for you, type of stuff. So it's really cool. There's Spring Web, which helps you set up like the your controller, which is the part that talks to your front end. So quick spiel, you have like three parts of your backend, basically most of the time. You have your models, you have your repository, and you have your controller. If you want to get fancy, you can have services in between your controller and your repository. You can also have DTOs and mappers and stuff like that. But basically, you have your entity, you have your repository, which is the part that really talks to your database, and you have your controller, which talks to your front end. It's the stuff like your controller is the code that has this link. It has a method and then it has a link on top of it. And when anyone goes to that link, it runs that method and gives them whatever that method, it does whatever that method says it should do. So Spring Web helps you set that up, uh, basically. And it uses annotations, which are like the at sign and some code to save you a lot of time and save you a lot of work. As long as you do things in the way that it assumes you're going to. But if you want to do something slightly unique, which it's Java, why would you? But if you want to do something that's a bit off the beaten path, it can take a lot of configuration to get Spring to do what you want it to do. That's the downside. I've never run into that problem. Just kidding, I have, but it's pretty rare. Most of the time, if you're building a Java backend, it's pretty standard, like what you want. There's, it's pretty, most of the time, you're just doing the same thing. All right, so week 7, to be honest, I did not listen in this part at all. The reason is that we were working on project 3, which was the big project, and we also had I was prepping for interviews and stuff like that. So, and we also were told that our end client wasn't really worried about this. So, um, so I can't really explain this except for OWASP. OWASP is something we were working on from week 1. It was really an every week thing, and it's really important. So it's the security protocols for how you should build a web app and the ways that hackers will try to access or exploit vulnerabilities in your web application. So I think there's 10, and if you're going to be a software engineer, especially a web developer, you should know these. Oh, is this what I think it is? Yeah, top 10 web application risks. Am I in the right place? I'm not sure. Okay, this is the big one. Um, yeah, basically, if you have a form on your website, an attacker will try to write SQL in that form and then send it because it knows that that data is going to your database anyway. So it might try to just get that, it might try to mask it and send it to your database and try to get your database to run that SQL statement. And it could be anything. It could tell it delete this database, basically delete a table in this database. It could tell it like give me every user's password. It could tell it whatever. So you need to put things in place to make sure that attackers, these are just the most common ways attackers will attack your website. OWASP tells you like these are the ways and how to best practices to make sure that it is not possible for them to do that. Not possible is a strong word. That it's difficult and that you're not vulnerable. So that's it. Kafka is a data streaming open source application. Is it an application? It's like, sure, we'll call it an application. So in between your front end and your back end, like just look it up, honestly. I have it in my head, but it's like if you, let's say you send a request from your front end to your back end, and for some reason it fails, right? And you don't get something back. If you can insert Kafka in between this front end and back end space. And so you send requests to Kafka. Kafka will send a request to your backend. It can like keep trying if your backend isn't available for some reason. It can cache like the results. Um, it's just kind of good practice, especially at scale. But a lot of if you're not really working on a large application that needs this, a lot of applications don't use it. So, but it's still good to know. I would say if you're a year into software engineering at a company, you're probably going to need to use Kafka or some solution that does what it does. ETL stands for extract, transform, load. I've never really done it, but it has to do with data warehousing. So it's like extract is like get the data, transform is like transform the data, load is like put it somewhere else. Um, if you look it up, you can get a lot more information. I have a friend I went to college with, and he's this kind of engineer. So there's software engineers that just do ETL basically, um, and they get paid. They get paid really good money. There's big data and Hadoop. The only thing I remember our instructor telling us about this, of course, big data is a buzzword. You can look it up, like you know, but I'm not gonna pretend like I've done it or taught or really been taught about it. And then there's Hadoop. Hadoop is, I think it's a way of processing data, and I think it uses Java. I think that's why we were taught about it. A lot of the data processing is done in Python, and I know R as well. But Hadoop, I let me make sure I'm right. Yep, it does. Okay. Well, great. Yeah, you could have just read this. Nice. Cool. There you go. So yeah, that is all 7 weeks. In how long? What should we say? 47 minutes? We'll just go back to one video because that's way shorter. Uh, yeah. So basically that's it. I also wanted to, maybe I'll do that in the next video. There's some YouTube channels that are really good at explaining some of this stuff, especially Java. But I'd recommend two things. One is this is the curriculum. This is literally what I learned. With there's some additional stuff as well, but this is big picture. So if you learn this stuff, just Google it, literally Google it, watch YouTube videos about it. I really like reading books. Once I've read about it and watched videos, I like moving on to reading books because you can get real deep and get real understanding. So do that. And then second thing is build projects with it. Um, you can even watch someone build a project. Revature training is good because your instructor is building the project and then you're following along, you're coding at the same time. That's different from what most people do. Most people just watch tutorials, which will not do it. You need like code along tutorials, kind of. So pick a project, something you want to build for yourself, and then you do it using Java, JavaScript, and SQL. Yeah, start with the database. There's this the main thing you want to use is dbeaver. So if you download or install dbeaver, you can create a database. I probably should have shown you guys this from the go. So you can create a database. It's kind of technical, but I'm sure there's videos about it. And you can run commands like SQL commands in here with a real database that you have. You can also connect to remote databases. You can just learn a lot about it. Just play around with it. And then once you have a database, try to build an API that connects to your database. That's it. It might take you like a month, 2 months. It's fine. It's fine. Trust me. The best part is just do it until you're frustrated. Take a walk. Come back, do it again. Try again. Take a walk. Ask ChatGPT about it. Take a walk. Like Sometimes it takes days of trying to do something and failing, especially on the parts where there are no resources. I was in it took me almost, I want to say, 3 weeks every day to spin up an EC2 instance on AWS and run like a backend on it and access it on a server owned by Amazon. Took me days because I didn't know Linux. I didn't know how to use a terminal. I didn't know that stuff. I had no idea what I was doing. I didn't know what sudo was. I had no idea. So that's fine. Just play around with it. Do your best. When you get frustrated, take a walk or whatever else you do to unwind. Um, if you don't get it that way that day, go to bed. Go to bed. Wake up. Try again. That's it. So the first thing I'd recommend is learning JavaScript, HTML, CSS, JavaScript, because you can demonstrate that to people. After you learn that, um, then I think you should learn backend. This is just one way of doing it. You should learn backend. If you don't know any Java at all, it'll take you some months to learn it and to be good enough to build a backend with it. That's in the days before ChatGPT. Now with AI, I don't know what's possible. It'll probably take you a lot shorter. You could also use Node.js, which is just JavaScript, but on the server. If you know JavaScript, use Node.js and then learn how APIs work that way. And then after that, build a database. I think that's probably the optimal learning point. You could go the other way, but databases are kind of boring and you can't really see it. But if you start with a front end, like a website, you can see it and you can probably get a job just being a front end engineer, maybe, while you learn the back end and learn the database part. All right, guys. Yeah, if there's any part of this that you want me to go into detail more about, let me know. I will do it. But there's people out there that have explained this stuff way better. I understand this stuff well enough to build apps with it, but there's people that know this, like, they know it really well. So just find those videos and watch them and learn from them. What else? I got my new job is going really well. I haven't said anything about it. It's going really well. The first week was frustrating because I was putting a lot of pressure on myself to be really good in the first week, and I wasn't. A big part of that was learning a new front end framework and then getting to know the code base. I still don't think it's been 2 months. I still don't think I'm really good, but like I understand things a lot better. And every day I work, I understand like Vue, especially on the front end, I understand things better. I'm also learning the optimal way to build things. So not just getting it to work, but getting it to work when things get big, you know, and getting it to work so that other developers can work with it, like can use it. So not just what is a way, like how do I do this, but what's the best way to do this. That's what I'm learning. And it's good that I'm learning it. It's also challenging to learn it because it's like getting it to work is not enough. You know, you need to get it to work in the best way, the most performant way. So yeah, that's it. I'm learning a lot, like every day. And yeah, I just want to, everything I learn, I just want to make videos about it. And that also helps me learn it better, of course. And it's fun. So any video ideas you guys have or anything, just let me know. I've been trying to reply to messages and comments and stuff like that. I'll do better about that. I will do my best to do better about that. But feel free to message me like multiple times. I don't care. I don't mind. All right, guys. Hope all of you are doing well. Um, hope you're making progress on the stuff you want to do and want to achieve. Hope you're learning. Uh, yeah, take care.